that. And we have, first value, 5 numbers. Okay, so what is your first step in finding a standard deviation? Find the mean. So we're going to call this X, right? And then what do we get for the mean for these 5? So the mean is 4.4. What is your next step? So the X, or your mean, yeah, your X minus the mean, right? All right, and what do you get for that, for the first one? Negative 0.4. Negative 0.4. All right. 0.4, so a little more. All right, and then for 6 minus the mean. 6 minus, oh, 1.6 is that? All right. And then 5 minus the mean. And 3 minus the mean. Negative 1.4. Negative 1.4, and then 4 minus the mean. Negative 0.4. All right. What is the step here to make sure that we did all the calculations right? Add them together, and they should make 0. Yep. Because that's the definition of your mean. It brings everything to a level. So adding them all up again, it should bring you back to 0. Back to what? It's supposed to bring you to 0 because that's the kind of definition of an average is all together. It'll even out to be the average. So then we get 0 and we add those all up. This can also kind of help to remind you of the next step, because there's not a whole lot we can do with 0. We have our negatives and positives, they're going to be 0. So what is the next step here in your negatives? Yep. No, your X minus the mean squared. All right. And what do we get for the negative 0.4 squared? 0.16, and then for 1.6 squared? 2.56. And 0.6 squared. And negative 1.4 squared. 1.96. And then we already did the calculations for negative 0.4, and we had our 0.1. All right. So now we squared it, got rid of all the negatives. What's the next step? And add them all together. Then they're supposed to, they're not. And really, I think it kind of is a little confusing when you think of this as 2 separate steps. Instead of just adding them, I think it's easier to think that now you're taking an average of all this. Because this is telling you how far away everything is from your mean. Yeah, from your mean of the data. So I like to think of this as now taking the average. Because remember that your next step after adding them all up is then to divide them by the number of points. So instead of thinking of it as 2 steps, I mean, you thought of this as 1 step, and I'll really think of that as 1 step, because I know that's a place where a lot of people went wrong on the exam was forgetting to keep the average. So let's just do it as 1 step then and take the mean again. And what do you get? 1.04. And you have one final step. Square root of 1. Square root, because we squared it, we got to get rid of that, so now we take the square root of 1.04. And what do you think? 1.019. 1.019? And can anyone tell me, does that look like that's probably a decent answer for the standard deviation? How you would know? Yeah. Yep. It's the mean of the yep. Is this mean just from the squared out minus mean? Yep. So then, what would you do this to? It's not like a very specific numerical check, but just to look at that, and how would you decide if that seems like a square? Yes.
Just by looking at your data points on the left there, as far as the distance that they're apart, give you an estimate on your fault line.
Exactly. And you're looking at that, that's 1.019. It's about 1, and these all fall about 1 more or less away from the mean. So just trying to make sure you didn't make some horrible error in the middle. It's not going to be like a perfect, exact numerical answer. So one thing that I guess the study guide said was you won't necessarily be doing a calculation. You could be. I don't know for sure, but they said they want you to understand it more conceptually. So what is the difference between a standard deviation of, say, 1.019 and if you had a standard deviation of, say, like, I don't know, 22? What's the difference with your data set?
Would there be a really large number under the, like one number would be higher than the rest?
That would give you a standard deviation. Or a bigger standard deviation. It doesn't necessarily have to be only one that's bigger. I mean, it's basically just like how far spread apart they are. But yes, having one piece of data that was a lot bigger would give you a much bigger standard deviation. So it's about how far they all fall from. Yeah. The further apart that they all are, the bigger the standard deviation level. So if you had a data set that was something like, if you had like 2, 100,